Welcome to the CloudBank introductory video on cloud security. CloudBank is a collaborative project between UC Berkeley, UC San Diego, and the University of Washington, sponsored by the National Science Foundation to support research computing on the public cloud. To learn more about us, please visit cloudbank.org. These introductory videos are intended to help a research team decide if the public cloud is the right platform for their research computing needs. So first things first, is this short video an introduction to cloud security? Absolutely, yes it is. Is this a comprehensive technical training video? No, it is not. If you are new to the cloud, you'll need to spend more time learning the ropes. That is, proper training on keeping your account secure connected to the specific public cloud platform you will be using. The public clouds we work with are Amazon Web Services, Microsoft Azure, and the Google Cloud Platform. Let's bring in some logos. And each cloud provider has free online training resources specific to their cloud platform. We map these out in the CloudBank portal training section. Also, each cloud platform uses their own specific terminology, so with those slight differences in mind, here we'll try to use the most general terms. Security implies a threat or risk, so next let's identify a villain of some sort to consider. Snidely will do. And now that we're motivated to thwart him, let's compile some specific questions. Cloud security begins with, is my data and my code secure when I put it on the public cloud? We allocate cloud resources by means of a cloud account that controls access through an authentication process. So let's add this question, how do we control access to our cloud accounts? Now, what about connecting to the cloud console or portal through your browser, or via SSH or a remote desktop? Is that connection secure? Suppose your datasets involve real human beings and are therefore subject to federal privacy laws like HIPAA. You will have to dig deeper into the data security world. Working with private information is a common practice on the cloud, but it is not trivial. The process begins with a shared responsibility model, so let's sketch out what that means. Finally, the cloud is really a lot of computers shared by many people. So we want a sense of how our own resource pool is isolated from everyone else's cloud resource pool, given that they are all located in the same physical facility. This gives us the opportunity to introduce some terminology, the Virtual Private Cloud, or VPC. So we have a few questions to look at, and we are taking the time to provide a little depth of background in this video because we at CloudBank do not want to oversimplify the picture. Where we are headed is this: the cloud is secure, provided you take the time to learn and follow the protocols. So with this list of questions, let's begin at the end, starting with that last one. Just what is a virtual private cloud? Schematically, here is an actual cloud. Let's suppose it is Microsoft Azure, and it is connected to the internet, and eventually to a research team. So this would be a schematic of a researcher over on the left. And in the cloud, there's a rack of computers. Actually, a bunch of racks. No, really, a lot of racks of computers. And we want to start using a few of them. So good news, there is a logical construct called a virtual private cloud, or VPC, inside the big cloud that isolates our resources, like virtual machines, from the rest of the cloud. Nobody outside of our team can connect to our resources, and we can set up as many of these virtual private clouds as we like. The VPC itself has no cost, but there are costs associated with access traffic. The cloud uses network address translation to map a single IP address to the interior private network of the VPC. So this is a carefully controlled access path or gateway that limits access to our VPC. That's the basic idea of a virtual private cloud, a sort of first order introduction. They use the term VPC on the Amazon and Google clouds. On Azure, they say VNet or virtual network, but in all cases, the idea in short is logical isolation of resources. Now there's additional learning to be done in practice. Our CloudBank Research Computing Framework suggests administrator and builder roles for team members. These people would be responsible for setting up and costing secure VPCs in detail. Turning to our next two questions, shared responsibility and secure connectivity, shared responsibility is a bit subtle. The idea is that keeping your cloud computing infrastructure secure is a responsibility that you share with the cloud provider, like say Google. The provider does not want you to feel like security is your problem and your problem alone. They provide technology that has a lot of security features, and they provide training on how to use it. Also, the provider does not want to convey the idea that your cloud infrastructure will be secure automatically out of the box, so to speak. They make their cloud platform tech very flexible because flexibility lets you customize what you're building, but flexibility introduces complexity, and that in turn makes cloud security non-trivial. This is why they offer security training and more, including cloud certification programs. Okay, next, connectivity. Internet communication is described in terms of a series of layers from physical hardware up to sophisticated communication protocols, like BOCHI. In that stack, the transport layer uses a cryptographic protocol, and SSH uses something similar. As a result, we can be confident that our data is encrypted on its way in or out of the cloud. We can check that box. But let's go over 3 ways of connecting with the cloud that use different types of authentication. We start by connecting to the provider's cloud console or portal through a web browser. Typically, we authenticate with a username and password. And to be more secure, a multi-factor authentication or MFA step, like the Duo authentication app. From there, we progress to a more direct cloud connection, a command line interface or a programmatic API. This makes use of public and private access key strings that can be generated at will by the cloud provider. Access keys are like an automated version of a password. Using them often means storing them in a text file. This file can be encrypted, a good security precaution, but sometimes access keys remain in plain text format, which is not recommended. User access keys can be used to reserve and use cloud resources, and cloud resources cost money. So, like blank checks, access keys should be managed very carefully. They can be deleted at a moment's notice to render them void. So when in doubt, delete access keys. And every couple of months, delete your access keys. New keys are easy to generate. Finally, let's look at connecting to a virtual machine on the cloud using a key pair file. That is another plain text file. Typically it has a .pem or .ppk file extension. So in 2 of these 3 cases, we have sensitive information, connection strings, residing in text files. More sophisticated connection methods also exist. For example, authentication certificates that expire in a few hours. The big picture, CloudBank can help you set up and use secure connection methods with minimal burden on your research team members. We hope not much more than tapping on a smartphone to get into their work. Now let's turn for a moment to a cautionary tale featuring our inimical villain Snidely. One day, a researcher named Kilroy was working on his computer, and he created a Git repository directory called MyRepo. In this directory, he placed his Python data analysis code, and because he was working on the cloud, he also put his access key credentials file there to keep it handy. You can tell this isn't going to go well. To safeguard his work, he then used git push to sync with his GitHub version of this repository. But alas, Snidely had deployed a malicious robot to surf through open repositories on GitHub looking for access keys. But just in the nick of time, the researcher remembered that malicious bots like to surf GitHub, and so he quickly deleted the credentials file. Unhappily, however, he forgot that GitHub is all about software version control, so it retains a record of things that get deleted. And that malicious robot knows to scan old versions as well. And so the access keys were found after all, and used by the bot to spin up 250 powerful virtual machines to mine Bitcoin. This cost the researcher $8,000 per hour. If you're wondering, has this really happened? The answer is yes, it has, many times. And that's why we fret about cloud security. But to finish on a more positive note, these next remarks assume the viewer is familiar with the process of starting up a virtual machine or VM on the cloud. This particular example is worked on Amazon Web Services, and it makes use of a CIDR block. A CIDR block is a shorthand way of specifying a range of IP addresses. So this is a bit technical, but it should be easy enough to follow the general idea conceptually. CIDR, spelled CIDR, stands for Classless Interdomain Routing, for the record. If, on the Amazon cloud, we start up a virtual machine using the Amazon Web Services console, we are walked through the process by a wizard in 7 steps. There is a lot to fill out, but many of the details have default values. So we can get in the habit of just breezing through them, accepting the defaults as we go. When do we want to jump in and not use a default value? From a security perspective, a cloud virtual machine has inbound traffic rules, specifically what origin IP addresses are allowed to talk to this VM. This inbound rule is set in step 6 of 7 of the wizard, configuring a security group. The default value is these 5 zeros, and this translates to anywhere on the internet can try and connect to this virtual machine. Now I looked up the IP address of my home computer, 24.19, etc. And I got the IP address of the cloud virtual machine, 54.214, etc. And my goal is to connect to that machine using SSH. I have my key pair file all set up, but before I try to connect, I will change my virtual machine inbound CIDR block rule to 128.95.155, and so on. So this rule allows inbound traffic, like SSH connection requests, from only this 128, etc. IP address range. In other words, not my home computer IP address. So what happens? Answer: 100% packet loss from the ping, and SSH fails to connect. So good, that's what we intended. Now let's modify that CIDR block for virtual machine access to match my home computer IP address, 24.19 and so on. Now I try the SSH again, and this time it allows me to log in, no problem. So for simple tests, a wizard default is fine, but to build your team's research infrastructure, you would like to put some thought into restricting access. And this is a brief look at how to get started with that. To finish off our original questions, we use identity and access management tools to grant user account access to the cloud account, and we take considerable care with access strings. We also have infrastructure tools like roles and policies and inbound traffic CIDR block rules to further control access, in addition to isolating resources within virtual private clouds. Therefore, yes, the cloud is secure, provided your team takes on the training and follows security guidelines. If something seems difficult in the security process, don't give up and take the easy path. It may work, but it probably increases your risk. Rather, reach out to CloudBank and to the cloud provider and just figure out how to do it properly. This gives us all peace of mind, or all of us except for this guy, and that's what we're going for. Thank you so much for your attention.